go over scheduling with independent tasks. So an independent task basically just means that we go from our start to all of our tasks. We can do any of them, and then we go from all of those tasks, we can go to our end. So we don't really have to worry about anything coming before something else. It means we can do any of them in any order. It's just a matter of how long it takes. So in this example, we have basically our times. If we're doing the critical path algorithm, we're just going to make the critical times for each of these are just simply going to be how long it takes to do each of them. So when we do the critical path algorithm, we're going to list these based on which one we're going to do first. We're going to start with the biggest, and then we're going to move down to the smallest. This is a very easy way of doing the critical path. So when we start with 10, so 10 is our biggest. So we have processor 1 and processor 2. We're going to start with 10, and then we're going to move down. We have 9, then we have 8 is the next one. So we don't want to start with 7 until we've started 8. So we're going to cross that one out. All right, we're going to start 8. All right, then we're going to start our 7. So we start our 7. Good. All right, then we have 5 and 4. We're going to start both of those. And we finished 4, so do we want to just have 4 waiting? Well, it doesn't really matter if we finish 5 or not. So we're just going to move this one. So this is our wrong answer, and our answer is going to be C. So for this one, the finishing time is 22 hours. The optimal time, well, we don't have any idle time here, so there's no way we could move these around and shift them to make it any better. So our optimal time is simply just adding all of these up. So when we add them all up, we get 44, and we divide it by our number of processors, we get 22. So optimal time is also 22 hours. So our relative error is going to be calculated by doing 22 minus 22 over 22 times 100%, which is 0% or 0. So we're done. This one's an easy example. Now let's move on. So we're going to do the same thing on this one. We have a set of independent tasks, and we're going to schedule it with 3 processors. So we're going to start with the largest number and move to the smallest. So these aren't given in order of our largest. So we're going to look at it. Our largest number is D, and then our next largest number is G and E, which are both the same. So let's make sure we note that they're both the same. Then we have A. Then we have B and F, which are both the same. And then we have C at the very end. So if we're doing critical path, it doesn't matter which way we go. We're just going to start from the biggest and go to the smallest. So obviously we're going to start with D. Well, there's D, a D, and a D. Well, this one we didn't start with D, so we can go ahead and eliminate that one out of our answer. All right, the next thing we're going to be looking at is G and E. So we're going to start E and G, E and G. All right, we have E and G. This one does not have E and G, so we'll eliminate that one. Now we're going to have A. So A needs to start next. Well, this one doesn't start A until over here, so we can eliminate that one, and our answer is B. So this is our answer. We start A, then we start B or F, and then we do C last, and we have a little bit of idle time right here. So because they were both the same, we'd have to push it to the end. All right, so our total finishing time for this one is 11. Now we're going to find the optimal schedule using 3 processors for the same thing. So the optimal one is the one that gives us the least amount of time, and it follows all the rules. Well, do we have any rules in this one if they're independent tasks? No. So it really doesn't matter which one comes first as long as we have them all included. So which one finishes at the end with the shortest? Well, that one's 12. This one's 11. This one's 11. And this one's at 10. So this one right here is going to be our optimal time. So now when we calculate it, we're going to do our optimal finishing time of 10. Our relative error is going to be what we got in our algorithm. So algorithm minus optimal divided by optimal. So we're going to do 11 minus 10 divided by 10. So we're left, and then times 100%, which gives us 1/10, which is 10% as our relative error. So rounded 2 decimal places is just 10.00. All right, and we're done with that one.